Hello everyone, we are continuing down our path through linked code most common interview questions, and today we are doing binary right side view. Uh, Given the root of a binary, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. And there is a better description somewhere here. Yep, see. Uh, Give, Given the root of the binary, return the values of the rightmost node at each level of the tree from top to bottom. So for example, if this is the tree, we have to return the nodes, rightmost nodes at each level. Uh, so for example, 3, 3 would be the rightmost, and then 6 would be the rightmost. And since there is no right children of 5, so our 4 would be the rightmost node at 1 2 3 at fourth level. So at each level, rightmost node will have to calculate, no, not calculate, but return. Yeah. uh, I'll keep my notes handy in case I get stuck. uh, so what we can do is we can either do depth first search or breadth first search. Breadth first search, I believe, using Q, but I've never done that. Actually, I find I think depth first search is a little more easy in my opinion, because with breadth first search you have to maintain a queue, and I mean it's also easy, but I find depth first search a bit more convenient. Okay. Hmm. uh, if we can maintain an array, we are starting at the root, and instead of going to the left like we typically do in depth first search, we would go to right side, and then we'd have to keep track of the um, level 2. mm, okay, so we are at the first level. We will check because we will maintain an array of the elements. We will check if, okay, is the current level equal to the size of our array. If that is the case, then um, then we will like append this node to into our array, and then we'll visit its children, that is 2 and 3. Like instead of going to the left, we will traverse the right subtree, and at this level we will check, okay, now the height of our array uh, is 1 because there is 1 uh, in that. uh, but okay, but hang on. I think because initially the size of array will be 0. No, the root, we don't need to check the root. Root will go into the array anyway. Right? Because we don't really need to check the root. Root is always the rightmost, or root's the, yeah. Okay, so yeah, we can create a list of integers here. Result, new array list. Find right side view, and I'm gonna pass in my list, my result array, and then I'll pass in my, then we also need a counter for levels, and then of course the root. Right, let's create this function now. Void find right side view, integer, just result, and level, and tree node root. I think they need to increase the size of the spot. Where are the settings? It's too short for my likeness. Yep. I mean, it's still too short, but root. Okay, we will check if, do we need to check for the null? We can worry about that later, but we'll check. Okay, if the result size says is equal to the level that we are at, then we will add, yeah, we'll add root's value. Okay, so like I said, right side view, I pass in my list and level +1 and root dot right side view. And this is important, like we have to do it this way. We have to traverse the right side of the tree first. If you did it otherwise, if you first went to the left, it won't work. Left. Yep. Well, let's see. Okay, we'll be here. At this level, the size of the list is 0, so we'll add 1, and then we're visiting this, and at this level, since we're incrementing level by 1, for each recursion level. Yeah, so here the level is 1, the size of list is also 1, so we'll add a roots value, and then we will visit this thing here, and right, yeah, and now for the return. For this example, so you're starting here, starting at the root node, visiting the right children, right child, and then it has no okay, there's no children. Then we will return from here. Look, the function control returns here, and then we visit the this node, and at this level, since the counter would be 2, because yeah, at this level counter would be 2 because we're at the second level, but it should be 1. Yeah, the counter would be 1 here level. I don't know, I think I might have been saying level and okay, level I chose like the worst variable name, but at this root level would be 2, 1, 1, because we started at 0 and 1, and since there are 2 elements in our list, so there would be a mismatch in the size and level, so we won't append, we won't add, oh god, Python habit. Okay, we won't add this thing to our list, and then yeah, as we keep looking down, let's try function statement, return works fine. Wow, and the first time I tried this, of course I wasn't able to solve. Yeah, I did it last time. I did it with depth first search, breadth first search. This time I did it with depth first search. Next time I will do it with breadth first search again. Okay, so the first question for today, I'm gonna have to look at the second question.